Hello, I'm Dr. Revathi, Associate Professor in Physics, Department of Freshman Engineering, Marri Laxman Reddy, Institute of Technology and Management. Today we are going to learn about the ruby laser. Yesterday we learned helium neon laser. Now today we learn about ruby laser. This is another type of the laser. So same ruby laser construction, working principle, applications, advantages and disadvantages. So this ruby laser comes under the solid state laser. In solid state laser, we are using optical energy as a pumping source. That means light energy as a pumping source, and here we are using the gain media as in a solid material. In gain media, we are using the solid material. Okay. So for example, ruby laser. So we will go with the ruby laser. So ruby is in a crystal. It is in a crystal. Crystal means three-dimensional and periodic, and crystal means periodic and regular and periodic arrangement of atoms. A crystal means a regular and periodic arrangement of atoms. Okay. So this ruby comes under the solid state laser. So this was first discovered by the Manimon. So here from this ruby laser we are getting the output as in pulses of short duration. This short duration means microseconds, and this ruby laser is a 3-level laser. And another thing is the photon emitted is which is in red color with the wavelength of the emitted photon is about 694.3 nanometers. Could you remember the wavelength of the helium neon laser? The wavelength of the helium neon laser is 632.8 nanometers. This is red color. This is deep red color. Just even if a small change in the color also, the wavelength is also going to be changes. Okay. Don't confuse between these two emitted wavelengths. One is the red color and another one is the deep red color. So from helium neon laser, the output emitted photon wavelength is about 632.8 nanometers, whereas from ruby laser, the emitted photon has a wavelength of 694.3 nanometers. And this ruby laser is in a 3-level laser system, and it is having the output of the pulsed, not a continuous wave, pulsed waves. Okay. So this is in a solid state laser. Here we are using the optical pumping as an energy source to excite the atoms to participate in the population inversion. Okay. So let's go with the construction. See here the diagram. So here first of all, see, we need to remember that the 3 components. That component is, one is pumping source, second one is pumping source, second one is active medium, third one is optical resonator. Okay. These 3 components we need to check in each and every laser. Okay. So first we will go with the what is our active medium. Let us consider a ruby rod, cylindrical ruby rod. And ruby rod means this is a crystal. This crystal is ruby rod means this is a crystal. That ruby means Al2O3, aluminum oxide doped with the chromium. Aluminum oxide doped with the chromium. So we will discuss this one later. Okay. Let us consider a ruby rod. So this ruby rod is in a crystal. Ruby means here Al2O3 doped with the chromium atoms. Okay. So this ruby rod is our active medium. This ruby rod is our active medium. Then we are getting one component. Next one is pumping source. What is that? At pumping source. So now our flash lamp which is filled with the xenon. Our flash lamp which is filled with the xenon is roll over this ruby rod. Okay. And next, 2 mirrors are placed parallel to each other. So to the ruby rod, 2 mirrors are placed parallel to each other to the ruby rod. These 2 mirrors can act as an optical resonator. These 2 mirrors can act as an optical resonator. So this mirror is act as an M1 and this mirror act as an M2. Okay. So, and the whole system is kept in a coolant. The whole system is kept in a coolant. Coolant means here we are supplying the liquid nitrogens. We are supplying the liquid nitrogens. Okay. First, again we will see. So, let us consider a ruby rod. Ruby rod means this is in a crystal. That means ruby means here aluminum oxide doped with the chromium. So, and to this ruby rod, that means ruby rod consists of Al2O3 doped with chromium ions. This is our active material. This is our active material. And so, our pumping source. What is our pumping source means here? So, the xenon flash lamp roll over our ruby rod. This xenon flash lamp roll over the ruby rod is our pumping source, and two mirrors are placed parallel to the ruby rod. These two mirrors can act as an optical resonator. The ruby rod length is about 10 centimeters and the diameter is 0.5 centimeters. The length of the ruby rod is 10 centimeters and the diameter is 0.5 centimeters. Okay, here the whole system is placed in the coolant. That means here we are supplying the coolant as a liquid. Here if you see liquid nitrogen we are supplying. So why we are taking liquid nitrogen? So what is this Al2O3? So how much doping we are taken? So like this we will see. All these things in detail we will see. Here ruby means Al2O3. So this is our host material. That and crystal, I said that crystal. Crystal means a three-dimensional structure, a regular and periodic arrangement of the atoms. Okay. So to this host material, this is the initial material. To this initial material, we are doping a small amount of chromium. That small amount means 0.05%. So that means this is the pure material. For this pure material, we are doping. We are adding impurities. We are adding the foreign atoms. Okay. So due to these foreign atoms, what is going to be happen? What is going to be happen means maybe the structure is going to be changed or optical properties are going to change. Here we are going to see how the energy levels are going to be changed. How the energy transition is going to be. So here for our ruby Al2O3, we are adding a small amount of chromium ions. The small amount means 0.05. This adding of impurities we are going to call as doping. This is a pure material. To this pure material we are adding. So pure material we can also call as a host material. Okay, this is clear. So and next one is, here we are using the pumping source as a flash lamp which is producing the heat. So if it is producing the heat continuously, so at some level the operation is going to be stopped. So in order to avoid these things, we are using the liquid nitrogen as a coolant. So in order to avoid this one, we are using the liquid nitrogen as a coolant. This is the construction of a ruby laser. So let's see what is the type we are taking means type of the laser means solid state laser. The energy level here is 3-level energy system. The active media, what is our active media? Our active media means chromium doped Al2O3, aluminum oxide. So that is our active media. If you see, you can understand easily with this table. And our active center is chromium ions. With the help of the chromium ions only, we are seeing the changes in the energy transitions and the wavelength values. So that's why this chromium we are going to call as an active center. And the pumping method we are using the optical pumping with the help of the flash lamp. That means here we are using the pumping source. What is the pumping source? We are using the pumping source as here flash lamp filled with xenon. Flash lamp filled, that means xenon flash lamp we are using as our pumping source. And two mirrors here, two mirrors we are using as an optical resonator. And what is the nature of the output? The nature of the output is pulsed output. And here the output power is very low. What is the power of the output? So that means the power we are getting the low power output. And at which wavelength it is going to emit the photons means that wavelength is 69.34 nanometers. This is the deep red in color. Okay, this is the brief construction and this pumping sources and active media and everything about the ruby laser. Now let's goes to the working. Working means you need to remember that this is the energy level diagram. How the atoms are moving from ground level to excited state, then how they can participate in the population inversion, and finally how we are getting the this lasing action. Let's see here. This is the ground state, and this is an excited state, and this is in a metastable state. If you see here, we are using the optical pumping to supply the energy to the atoms in the ground state to move to the higher levels. So we are using the optical pumping as an energy source. So with the help of this energy source, the ground state atoms are started to move from ground state to the excited state. Now see here. Now the atoms are moving from ground state to the excited. How much energy we are giving here? What is the source we are, which source we are taking means we are taking the xenon flash lamp. Xenon flash lamp with a wavelength of, the wavelength of the xenon flash lamp is about 5500 angstroms. Okay. So this is going to incident on the atoms on the ground state, and the atoms absorb this energy and they started to move from the ground level to the excited level. Now the atoms are in the excited level. Okay. So in excited level, they will stay for the 10 power minus 8 seconds. Then after this 10 power minus 8 seconds, see here, the atoms comes to the metastable state. The atom comes to the metastable state. Here we are getting non-radiative transition. Non-radiative. There are two types of transitions. One is radiative and another one is the non-radiative. Non-radiative means the emitted energy is going to be used as a heat energy. It is not useful for us. So due to this also, our system is going to be heat up. That is another reason we are using the coolants also. From excited state to metastable state, what is going to happen? The atom is going to emit a photon. This photon is non-radiative. From here, we are getting the non-radiative transition. So heat energy only it is generating. So then here, if the process is continuous like this, what is going to be happen? So the population is created at the E2 level. The population is created at the E2 level because this is in a metastable state. That's why the atom will stay for the longer time. So we can also call these metastable states as an energy trapping states. Okay, because for a particular, for a some level, for longer lifetime, the atoms are going to be trapped with their energies there only. So we can call this metastable states also energy trapped levels. Energy trapped levels. So here the atoms will stay for the longer time. So here we are going to expect the population inversion condition. That means more number of atoms are accumulated in this state when compared to the ground state. And now after this, what is going to be happen? So the photon is emitted from E2 to E1. E2 to E1. So again what is happening? The photon is going to be emitted. See here, this is 1 and this is second. We will see here some small thing is there. If you observe this, this is a very easy energy level diagram. Okay. So from here, from E2 to E1, the photon is emitted. That means this is the spontaneous emitted photon. This is the spontaneous emitted photon. This is not the stimulated emission photon. This is the spontaneous emitted photon. So now what is going to be happen means this spontaneously emitted photon can be used as an energy for the atoms in the excited state. This photon can be used as an energy for the atoms in the higher level. Higher level means metastable atoms. Okay. So what happens now? We have already here means one photon is there. If this photon can be used as an excited state energy, so now what happens? So now this two, now for one atom, so 2 photons are going to be released. At first it is going to be emit spontaneous emission, and this spontaneously emitted photon can be used as an energy for the atoms in the metastable state. After this, what happens? The atom will emit to the again ground state. Now it is emitting not one photon, it is emitting the 2 photons. This 2 photon for one atom, it is emitting in 2 photons. That means if 2 atoms it is emitting, that means it is going to be multiply, and finally we are getting the amplified laser beam out. So the output of the laser beam falls under the region of the visible region with the wavelength of the 6,943.3 nanometers, 694.3 nanometers, 6,943 angstroms. This is the deep red in color. Okay, this is very easy. So now if we switch on the flash lamp, we incident the flashlight on the atoms in the ground state. So the wavelength of the xenon flash lamp is about 5,500 angstroms. Okay, if you incident on the atoms in the ground state, the atoms will absorb this energy and they started to move to the excited state. Okay, after the lifetime of the excited state, the atom will comes to the metastable state. The atom will comes to the metastable state, and here the atom will stay for the long time. Okay, so now and here after that the atom will goes to the ground state by emitting photon. This photon emission we are going to call as a spontaneously emitted photon. So this spontaneously, we need stimulated emission, not the spontaneous emission. This spontaneously emitted photon can be used as an energy for the atoms in the metastable state. So now the atom will take this spontaneously emitted photon energy, and they started to move from E2 to E1. They started to move from E2 to E1. So downward transition. So now while emitting, how many photons it is going to emit? For one atom it is going to emit 2 photons. So these 2 photons are going to follow the properties of the laser, and the emitted photon has a wavelength of 6,943 angstrom. It is under the visible region and the color is deep red in color. Okay, so this is the energy level diagram of the ruby laser. Okay, so next. And as I told, this ruby laser is going to give the pulses. And yesterday we saw helium neon is a continuous wave. That means the output is continuous, constant, without any changing. Okay, so output is continuous. But whereas if you see here for ruby laser, so pulses short, these pulses also having short duration, milliseconds only, short duration. Okay, whereas for continuous laser, so the way the output is continuous, there is no short pulses. And okay, this is the major difference between the continuous wave output and the pulsed output. And what are the advantages of the ruby laser? So ruby laser also very easy to construct and operate. And next one is it is having high degree of coherence. And next one is the output power. It is having the high output power. How much it is going to give me? 10 power 4 to 10 power 6 watts when compared to the helium neon laser. And ruby crystal is very strong and durable. Over the time, we couldn't see any degradations. We couldn't see any defects in the crystal. So the crystal is good. So it is going to work very nicely. So and it is also having very good thermal properties. So this is the advantages of the ruby laser. And next, what are the disadvantages? Means okay, so we can't grow the ruby rod in larger dimensions. We can't grow because it is very narrow diameter of 0.5 centimeters and the length is about 50 centimeters. And here it produces the pulses. It produces the pulses output, but this pulse duration is also very short. This is in microseconds. And next one is it is going to produce very heat. So that's why effective heating system is going to be arranged. These are the disadvantages. So what are the applications? Ruby lasers we are used in industrial cutting and welding. Purpose, and also ruby laser we can use for removal of the hair and the tattoos. Tattoos also we can remove with the help of the ruby lasers, and it can be used in holography, decoration, displays and display devices and toys also. Okay, so these are the references. If you want, you can check it. Okay, thank you.